to be in one parenthesis n plus 13 times n minus 5. And I got that because 65 can go into 1 and 65 and 5 and 13. And you know that it's going to be mixed because of the negative 65. And yeah. So that'd be a positive 13 and a negative 5. And then I check my work.
Good. Any questions on 14? Thanks. Perfect. So Josh has 20.
Okay, so the original equation for number 20 was c squared plus 28c plus 196. And so it factors to be c plus 14 squared because the square root of 196 is 14 and 14 plus 14 is 28.
Any questions for Josh? Josh, what type of problem was that called? A what? Factoring? What's special about those numbers?
Oh, they're special
Special squares, special patterns, yeah. So number 20 was a special pattern. Make sure you have that factored. If they are a special pattern, Josh, can I have that back? Sorry. But when you're factoring this, 196 is a perfect square. So when you're factoring it, make sure you have your quantity as a perfect square. So down here, he has it kind of factored, showing you how 14 and 14 make 28. Do not leave them as two separate parentheses. When the parentheses are the same, they get combined together, and it is a perfect square. So that perfect square is showing that the quantity is the same, placing the two outside. So please make sure that you're looking at the last set of problems that were perfect squares. If it was a trinomial, it should be one quantity with the little squared outside. If it was two terms, and then it's a plus and a minus, those are going to be separate parentheses. But make sure you're checking that. So if it's a perfect square, it should be written as a perfect squared quantity as well. Anyone else have questions on the factoring homework? How many of them couldn't be factored? Two. Yeah, two of them should not have been factorable. So not all problems can factor because sometimes there's just not numbers. That one's not factorable. That one's not factorable. But sometimes there's not numbers that are going to add to be in the middle. So not everything factors. Questions? So in your notes, we just have a little tiny page to kind of talk about today. As I said, we're going to look at something called a zero and something called a root. So it should just be the back of the page from Tuesday. Just a little page. So this is part 2, section 4.3, still factoring. But today we're going to try and solve. So one of the main goals of algebra is to solve for x. Whether it's an x squared, or an x to the 1/2, or an x in the denominator of an equation, an x cubed. We're going to see many different types of equations dealing with x. But that's really one of the main goals of algebra, solving for x. So one of the ways we can solve for x is by factoring, and we're going to go over like 5 different ways we can solve for x in this chapter. So 2 different terms here. We have a root of an equation versus a zero of a function. And in a sense, they are the same word. They're equivalent words, but it kind of depends on what you're finding. So a root of an equation is a solution to a quadratic equation. Remember, a solution is the answer for x. And we talked about that quadratic equation is when the problem is equal to 0. So quadratic equation, an equation when it's in quadratic form is when it's equal to 0. So a root is the same thing as a solution, which is the same thing as an answer. We're trying to find x. So if your question said find the root of the equation, because that's what it's going to say, that's the math, the algebra word. Really, that means we're finding the solution. We want to solve for x because it was equal to 0. The second one says a zero of a function, so this is our other word. A zero of a function is an x-intercept. Does anybody remember what an x? This was supposed to say quadratic. Anybody remember what an x-intercept is? I have a rough time spelling. What's an x-intercept? Jack.
When y equals 0.
When y equals 0. And it has to cross what?
The x-axis.
The x-axis. So a 0 is an x-intercept of the function f of x equals ax squared plus bx plus c when our function, or our y, is equal to 0. Which really means we're still finding x because I'm going to take this function, I'm going to change it to 0, and we're finding x. However, x-intercepts are written as ordered pairs because the y is 0. So I'm going to have one x value, I'm going to have a different x value. So the way you write your answer is different, but the way you find it is the same. So a solution is just x equals. A 0 is a point because it's an x-intercept on the graph. It's where the graph crosses the y-axis, or the x-axis. So we write an intercept or a 0 differently than I would write a root or a solution. But you're doing it the same way. So essentially they mean the same thing, it's just you're writing your answer slightly differently. So if you look at I think there's 2 questions underneath. Oh, no, there's a little product property here first. So the 0 product property. If the product of 2 expressions, which is why we factor to break it into multiplication, because that breaks the problem down, is 0, then one or both of the expressions also equals 0. So if I have 2 things I'm multiplying together, and the whole expression is equal to 0, then one of those expressions has to be 0, because 0 times something equals 0. Or both of them can be 0, because 0 times 0 also equals 0. Kind of makes sense. A lot of math properties and theories are facts that somebody a long time ago created to make it a fact so that we can use it. The algebra part says a and b are expressions. A times b is 0. So this is the 0 product property. So they have to multiply together to be 0. So then again, either the a is 0 or the b is 0. Or both. So how does that work for us? And this is a product property that you will use throughout all of math. So it's a property that gets used when you're solving. So if I have something factored, so this is my factored answer of all your problems last night. But now that factor is equal to 0, and it must equal 0. That's what the product property says. If it's equal to 0, then we can split apart those two factors and solve individually for x. So I can take the x plus 5 and set it equal to 0 because that's like my expression for a. I can take the x plus 2, also set it equal to 0 because that's my expression for b. So it's a way to find x. That's what the zero product property says. So if I solve for both of them, Chris, x plus 5 equals 0. So that means in that expression, x is equal to negative 5. Or x plus 2 equals 0, Chris. So in that expression, x would be negative 2. So now I have a way to find x. That's what the zero product property says. But it has to be equal to 0. If it's equal to anything else, you cannot solve it. So it must equal 0. And then if it does, I can find the values for x. Because that's how you solve a quadratic equation. So quadratic equation must equal 0 to solve it. So if you look, I think there's two examples. So this one says find the roots, which means find the solutions. It's equal to 0. So we have x squared minus 2x minus 15 equals 0. How would you factor that? Nick, how would you factor it?
X plus 3, x minus 5.
Yep, so x plus 3 and x minus 5. So my factors of 15 would be 3 and negative 5. So we would write them in parentheses, factoring in x plus 3, x minus 5. It's a negative 2, so the larger value needs to be negative. So now the zero product property says I can split these two apart to solve. One of them or both of them can equal 0. So Nick, your two solutions would be?
Negative 3 and 5.
Yeah, negative 3 or positive 5. It could be one of them or it could be both of them. So those would be our solutions. That's it. So the next question says find the zeros of the function by writing the function in intercept form. Intercept form is factored form. So we have all these like little terms. They all mean something. So intercept form means pretty much write it as factored form. Factored form means a product of multiplication, a product of factors. So find the zeros of the function. Jack said you find a 0. Jack, a 0 is an x-intercept, which means y is 0. So we find a 0 of a function by making our y equal to 0. A 0 is an intercept. Specifically the x. So we still need to factor this. Michael, how would you factor x squared plus 5x minus 6? What two numbers would multiply to be negative 6?
Negative 1 and 6.
So he said negative 1 and 6. Oops, I already had a parenthesis there. And then, Michael, my two x values would be?
1 and negative 6.
Right. However, this one says to find the zeros. So I can't leave my answer like this. So this is the only difference. It's how you write your answer. So because I'm finding an x-intercept, my answer needs to be 1, 0 and negative 6, 0. And I want you, we're going to graph this in the calculator, even though there's a little picture here. I want to show you how you can use the calculator to find this as well. So the only difference between the two will be the terminology and how you write your answer. So a root is a solution, x equals. A 0 is an intercept, so I write it as a point because it actually references the graph. So we're going to look at this graph. And I know the picture is already there, but I want to show you how the calculator can help you find this as well, so that you can kind of see how the calculator can help you check some answers. So if you hit the graph, does anybody know what the shape of this graph is called? Peter?
Parabola.
Yeah, this is a parabola. So this will be the shape that we find, use all chapter. So any graph that has an x squared in it makes a parabola. Any graph that's in mx plus b form makes a line. Any graph that has absolute values makes a v. So we're really going to be talking about like the shapes of the graph as we continue working through. But every graph that we do this chapter is going to look like this. So the zeros would be where your graph crosses the x-axis. Visually, you can see them pretty quickly. Because I can see I have one over here and I have one here. But I want you to also kind of see how the calculator can help you find them. So the calculator, if you hit the second button and calculate. So over here is second, and then my calculate is right next to graph. We will be using, we already did number 5, intersect, last chapter, but we're going to be using 1, 2, 3, and 4 as well. We're finding a 0, which is number 2. So the calculator finds that for you as well. So if you hit number 2, here's the weird part of the calculator. It says left bound. We need to trap the intercept between two numbers. So right here's my intercept. And I need to pretty much trap it between two numbers so that it can calculate it. I need a number on the left and I need a number on the right. So if this is my intercept, and we said it was -6, my left bound, I'm going to put a number slightly to the left of it. So I'm going to hit -7. So I need a number that's to the left of where I think my x-intercept is. And then I hit enter. And then you get a little caret arrow at the top. Right bound means I need a number slightly to the right of it, which if my 0 is at -6, I would type in -5. And then I would hit enter. And now I have these two arrows pointing towards each other, and in between there should be my x-intercept. And if you hit enter one more time, you never do anything for guess, that's just the calculator kind of pulling the material together. It tells you that your 0 is at -60. This is really beneficial when your 0 is a decimal. So right now it's a whole number, and you can visually see what's going on, Jack.
For me, it says x equals -6, y equals -1, e minus
Yeah.
12.
So that's giving you scientific notation. Sometimes the calculator just won't get this number to go directly to 0, but that is scientific notation of having, how many did you say, -12?
Yeah.
So that's having like 0.00000000000. So it's extremely tiny. You can just say the number is 0. Did anybody else's calculator do that? Give you scientific notation? Yeah. Sometimes it does that. Other times it doesn't. I have no clue why. Nina?
So when you put it into like the left bound,
Mhm.
you put in like if it's over on the -7, you put -7 or just 7?
Yeah, -7. So whatever is on the left of that number. Yeah. So let's try it again. So let's see if we can do the other side. And Jack, this time it might give you 0 instead of giving you that scientific notation. So if it gives you scientific notation, just write 0 anyway. It's just the calculator can't quite get it to be 0 for some strange reason. So if I'm now finding this one over here, that's the number 1. So left bound, something to the left of 1. What number would be to the left of 1? 0. So I type 0, hit enter. Right bound, something to the right of +1 would be 2. I would hit enter. Guess, you never do anything but hit enter. And then I have my second 0 that I found with the calculator. So again, when their numbers are whole numbers, which right now they're going to be whole numbers, tomorrow they'll start switching to decimals or fractions. It's not really beneficial to use. But it is a way to check your answers. And it's a way to calculate zeros, especially once they start becoming more complex numbers. Questions?
So wait, should you always try to get it like the closest?
The closest that you can to it, yeah. So if you're like 1 away from it. Yeah. Other questions? Did it give you, Jack, did it give you scientific notation again?
It gave you 0.
It gave you 0, yeah. I don't know. So we have about 18 minutes, 20 minutes, what does it say? 19 minutes? As I said, tomorrow we're going to do still factoring, but we call it the AC grouping method. It's factoring with a coefficient in front of that x squared. kind of tweaks the way that we have to factor, because we have to take into account there's a number in front of x. So we're gonna do the odds on this worksheet. So 1 to 39 odd. If you flip it over, there are answers to all of them on the back, and actually to 40 and 41, which I took off so that I could put the answers in there. We're gonna do 40 and 41 next week in an application couple of days that we'll do all word problems together. So answers at the bottom, make sure you're checking your answers. Show a little bit of work, as it says, if the problem cannot be factored, make sure you say so. But when you're solving, try and make sure that you are like solving it, writing the solution, x equals. Anybody have questions?
Do you need to do this on like a separate piece of
No, this one actually you can do on this page, because I copied it from a different location, so there is definitely space for you to just do on this worksheet. So you can do the assignment on this worksheet. And the factoring is mixed, so you'll have to look, some of them are perfect squares, check to see that you've got like a perfect square problem.
There's no wrong with calculators, because I've had these saved set up as yours. I hit graph, and I just get a straight line.
Okay, so if you hit zoom and hit number 6.
Okay, thank you.
Yep, so your calculator screen was just kind of out of whack, I would say, just wasn't centered around the zeros either.
Thank you.
Wait. Wait, what's this factor? Should we just do that?
Yep, so factor means your answer should just be multiplication. So you're not gonna start solving till it's equal to 0.
Should I still say what?
Nope. So factoring those first group of problems, your answers should just be parentheses, you don't have to say what x is equal to.